It's an interesting phenomenon, though. It's one that once it starts, it's very difficult to stop it. And that's part of the problem with climate change. Polar bears have become supremely adapted to a life of ice and snow. They depend on it for movement. They move, much of their life is moving across ice. It's much easier to walk on. They depend on it for movement, for mating, and for foraging. And there's no question that reductions in snow and ice are going to affect them. Ring seals are the primary food of polar bears. Most hunting is done in late spring, just prior to sea ice breakup. This is a time when seal pups are rapidly gaining weight in their little subnivean layers. And the bears find these layers, break into them, and eat the pups. They also lie quietly beside breeding holes, breaks in the pack ice, or the edges of various size ice floes, and wait very patiently for unsuspecting adult seals. And they're quite effective at killing them and eating the whole thing. They also known to kill and eat much larger marine species, such as beluga whales. And sometimes they really find some large marine critters, and if they could just get them open. And I talked to one of the fellows on this submarine in email, and he said that when this guy was doing this, which is a standard way the polar bears break through ice to get to seals, the noise was deafening. And the captain of the vessel finally had them submerge because they just couldn't put up with the noise. While the loss of sea ice will impact spring seal hunting across the entire range of polar bears, the impact is going to be especially acute in the Hudson Bay region. These bears normally shift to a terrestrial existence during the 4 to 5 month ice-free period and are thought not to forage to any great extent, subsisting instead of stored fat reserves. And those reserves, of course, come primarily from the spring seal hunting. So recent analyses have shown declines in the body condition, reproductive success, survival, and population size of polar bears in the western Hudson Bay population that are coincident with an advance in spring breakup. Now, we can't say it causes it. They just happen at the same time. It's likely, but that's not proof. It's argued that these declines are caused by an energy deficit related to the loss of spring seal hunting opportunities, a deficit that then continues due to fasting during the ice-free period. Now, 4 studies have examined sea ice breakup in western Hudson Bay and indicate that it's advancing at about 0.72 days per year. So each year the ice breaks up a little bit earlier. Studies with radio-collared females have shown that sea ice breakup is a reasonable surrogate for the onshore arrival of these polar bears. So these analyses are all telling us that bears are coming ashore sooner. Now, this has been used to argue that all is lost, everything's going to go away, and so on and so forth. Ironically, the advance in breakup that may result in polar bears coming ashore with an energy deficit could provide them with an alternate energy source. Most of the bears of the West Hudson Bay population come ashore along this coastline. And this is an area of nesting snow geese. As you'll learn tomorrow, when I first started working there, they all nested here. But we all know that snow goose populations have exploded. They're not stupid. They've moved down the coast. So the snow geese occur along this entire area. And what happens is, if bears are coming ashore earlier, it's possible that there's an alternate food source. And just to jump ahead a minute, there's 60,000 pairs of snow geese. So no, 1 egg is not the same as 1 seal, but these guys lay 4 eggs apiece, and there's 60,000 pairs of them. So that's a few more calories. And this got us started thinking. Historically, polar bears arrived after the geese had hatched their clutches. And polar bears are known to catch and eat both juvenile and adult geese, but there is a metabolic expense associated with running them down. However, at least my research shows that eggs don't run very fast. And if the polar bears arrive early enough to overlap the incubation period, there's going to be some easy food available. Well, the first question is, has global climate change caused the incubation period of snow geese to advance? And it's important to establish that, because there's going to be little opportunity for overlap if the incubation period is advancing at the same rate that the sea ice is advancing. That would just be sort of like the Red Queen hypothesis in Alice in Wonderland. So we examined this to start with, and we used the long-term data set from La Perouse Bay, and we showed that, yeah, there's a decline in the average nesting period and incubation date, but it's a lot less. It's only 0.16 days per year rather than 0.72. So it's less than 22% of the rate of advance in sea ice breakup. So this slower advance is related to the fact that nesting snow geese respond partly to photoperiod, not just melting of things. And photoperiod isn't affected by global climate change. Sun still comes up the same time. Photoperiod still works the same way. So geese are responding to, in part, a different set of cues than the polar bears. So at some point, just with what I've shown you so far, it makes sense that polar bears will be arriving on shore during the incubation period of snow geese. So the next question is, how much energy is there in a snow goose egg? Well, bears can certainly digest both the lipids found mainly in the yolk and the protein that's found primarily in the egg's white, or albumin. And the energy content of an egg declines over the incubation period, this nice little pattern here, simply because the developing embryo uses some of the energy in developing itself from an egg into a gosling. So this is what the energy profile looks like. The next question then is, the next fact is that snow geese don't all lay their eggs on the same day. It spans about a 7-day period where about 6% start laying on day 1 and another 11% on day 2 and right on down the pike, so that you have a 33-day period. And during that period, eggs are getting older and less valued, but there's more of them at the beginning. So we have a real upswing here as more and more geese start laying their eggs. And then we have a decline, that's the last curve I showed you, the decline in value of an egg. And then all of a sudden, the guys that laid theirs first hatch theirs first, and they leave. And very quickly, it goes down to very little. So here's the window of energy provided by snow goose eggs. And this is just eggs, because remember, they don't run. There's no metabolic cost to eating them. So, do polar bears actually eat goose eggs? This has been quite contentious. A lot of people don't believe me when I say they do. Well, Yucca Prop on Svalbard has seen them eating eggs. And Linda Gormazano, who analyzes polar bear poop, we'll come back to that in a little bit, has found that she's seen the eggs come out. So we've got good evidence that eggs go in. We have good evidence that eggs come out the other end. You'll notice the yolk and albumin aren't included, so I think we can conclude that they use some of that. Next, how much energy does a polar bear need to compensate for lost seal hunting opportunities? Now, this is a crucial part of this argument, and it's one that some of the experts seem to have avoided. We're not saying that polar bears will suddenly switch to only eating geese. We're saying that if they come ashore earlier and lose some of the hunting opportunities of seals, they're going to build up an energy deficit. And we're interested in how much of that deficit can be compensated for by snow goose eggs. So, in computing the energy value, we have to account for age-specific differences in seal caloric content. Seal puppies are worth more than slightly older seals because they have higher fat content and so on and so forth. On average, the bear obtains 22,432 calories of energy per day from consuming a seal in the spring. We call this a seal day. So equivalently, for every day of lost spring seal hunting, a polar bear incurs a deficit of 22,432 calories. So if a polar bear arrived at the peak of the energy profile when the entire colony had just begun incubating, it would need to consume the eggs from 27 nests to compensate for one seal day. Remember, there's 60,000 nests. There'd be 48,855 such nests given the staggered initiation time that's available to be divided up 27 nests per bear to do compensating for one lost seal day. So we've recorded 6 polar bears ashore during the incubation period of lesser snow geese, and 4 of those have been since 2000. In all cases, the bears were observed within the nesting area, and the size and lack of facial scars were most consistent with them being subadults. In 4 cases, we were able to follow the tracks of individuals through the nesting colony until they disappeared. For one bear, he walked right past the nest and ate nothing. The other 3, they ate 5, 11, and 16 clutches. Although these are certainly underestimates because you can't follow the bear tracks everywhere and you can't walk the whole way and you don't want to approach the bear. So this was just to show that, yes, when they do come ashore, they do eat the eggs, and it's been happening, but it's just started. So if we now add this data to our energy profile, what we find is the current situation in the Cape Churchill Peninsula. And that is, this is the energy profile, and this is when the bears are now arriving. So they're just starting to overlap. The mean advances in onshore arrival of polar bears is 4.5 times faster than the advance in the incubation period of the geese. So as such, this is going to move this way faster than this curve is going to move this way. So increasingly, the earlier bear gets better food, all right, because he's going to intersect this supply curve further over when the caloric value is higher. Now, at the current level of overlap with the incubation period, a bear would actually have to consume the eggs from 43 nests to compensate for 1 day's lost spring seal hunting. And since bears are currently arriving when many of the pairs have already left with their broods, there would only be 8,300 and some nests to choose from, an overall reservoir of 190 seal days on the colony right now. Given another decade of global change, however, the extent of overlap will have advanced by 5.6 days, and the bears will need to consume the eggs from only 34 nests for compensation, again, the earlier bear. Because this is before any of the geese hatch their clutches, there's going to be 48,855 to choose from. So there's a lot more resources that will be available a little bit down the road. Polar bears do not all come ashore at the same time, and their arrival is also not random, since subadults tend to arrive first. And this likely stems from competition at feeding sites, where the big guys take over the good spots, the little guys get chased ashore. So it's likely the subadults, that's what we've seen, and they're the first ones that are going to come ashore. Subadults represent about 25% of the population, and unlike prime-age bears, subadults have recently suffered a 2 to 5% decline in annual survival rate. So if this is due to accrued energy deficits, then compensation from snow goose eggs should improve the bear's condition and might reverse the survival decline. And given the relative importance of survival to population dynamics, such an increase will raise the near-term growth rate, and owing to momentum, will also temporarily raise the population size. How much would a polar bear eat? Well, we saw one subadult male that came ashore after the snow geese had hatched, but while common eiders were still nesting. He walked from island to island foraging on eider nests, and during a 96-hour period consumed 206 of the approximately 325 active nests, 4 eggs each. This amounts to 170,000 kilocalories, or 7.5 seal days in just 96 hours. Now, to put this in perspective, the best guess anybody has is that a polar bear needs 40 seals per year to maintain weight and to survive. So this guy got 7.5 of them in 96 hours. They're capable of eating a lot. They can consume up to 10% of their body mass in 30 minutes. Their stomachs can hold up to 20% of their body mass. For a 1,200-pound male bear, that's a lot of food. So whether eggs from the snow goose nesting colony will be consumed by an early arriving gluttonous bear, a few of them, or a larger number of the population is going to depend on polar bear behavior and arrival dynamics. And since this is just starting, we don't know much about that. So this is sort of positive news for the polar bears. Very little, though, is known about how this is going to affect the nesting geese, and more importantly, their potential as a long-term resource for the bears. For example, Will a female goose whose nest is depredated return to the area and nest again the following year? Well, evidence from Sweden and Svalbard suggests that they actually do that. And of course, what effect will such egg consumption have on overall goose abundance? And again, there is some evidence that goose populations on Svalbard are declining, but the limits and dynamics are very poorly understood. So, when we don't know a lot about biological systems, we often turn to models. And just so that everybody's clear, this is the model moose, and this is the real moose. So we use models to try to understand the limits of things we don't understand very well. And they're especially useful in understanding the limits of real systems. So in our case, we used computer models to examine several possibilities, ranging from total destruction of the nesting population to sort of a quasi-equilibrium in which goose nests could serve as a renewable nutritional resource for the bears. So the processes underlying snow goose incubation and onshore arrival of bears are stochastic, they're partially independent, and they're climate-driven. There are going to be years when early ice out coincides with late nesting, and the onshore arrival of bears will match. So that's this whole red area. So this is the bears matching the geese. There's also going to be times when early nesting and late ice out results in a mismatch. And remember, this is stochastic, so it happens sort of randomly. So we use what are called stochastic ARMA models to provide the best fit to both processes. And in both cases, the dates have advanced over the years, but both processes display what are called autoregressions and moving averages, some things that violate some of the lofty, easy assumptions that we made earlier. And so what we wanted to do was take our best models that fit this distribution for the hatch date and this distribution for ice out, and see what happens when you consider them jointly. And what you get is a diagram that looks like this. And the important thing for you to notice is that we have match. These are years when the polar bears overlap. Mismatch. These are years when the polar bears don't match. And if you look, you sort of think, well, this is going up a little bit, but there's a lot of noise going on. And I projected this out for 25 years. It makes a little more sense if we look at just the mean and the upper and lower 25 percentiles. And again, what we see is that over the 25 years, there's a slow increase in the amount of match. And if we look at this just numerically, what we see is at 25 years, there's going to be about a 12-day match. And this is the best model, but all of the models come up with about the same answer. All right? And that's the point I want to make. The extent of overlap expected between onshore arrival of polar bears and the snow goose incubation period, when we account for all of this stochasticity in global climate change, is amounting to about 12 years, or 12 days in 25 years. So, we examine the effect of polar bear egg depredation associated with this increasing onshore overlap on the dynamics of the snow geese using just a standard life cycle model. And basically, this is easy to understand. These are birds in age class 1, 2, 3, 4, and 5 and older. And these are the probabilities that you live those times, and these are the reproductive success values. And this is just the way you organize them. Snow geese have a survival probability of 0.833, and this is their reproductive output in the absence of any polar bear depredation. We then come up with one alternate matrix, which is there's no reproductive success. And then we model the population by combining it, and we say, okay, in a year that matches, then some proportion will have the good matrix and some proportion will have the bad matrix. And what does that do to the snow goose population? That's the real key here. So this is what it sort of looks like for just 20 trials of this. And we see that despite some early sort of inertia, the population declines. Now, this is a case where when there is overlap, all of the eggs are destroyed, all right? And if we look at that, we see something really interesting. This is, again, the mean of all of 10,000 or of 1,000 trials and the 25 or the 5%, 95% confidence limits on it. And this little dotted line is the deterministic projection. And I want you to pay particular attention to that. In a stochastic world where we allow for all the variation, there's a decline, but that curve looks very different than this curve. And both of these systems began with 2 days of overlap and ended with 12 days of overlap. Now, what's going on here? Well, what happens is the deterministic model, there's no chance variation. Everything just clicks along without any variability at all. And basically, it follows this line right here. So there's always a match. So bears are always eating the eggs. So there's this decline. And you go, well, why is this one looking this way? Well, what happens is, early in the stochastic projection, which is here, we have periodic matches that are farther up the curve than the deterministic one. They're up in this area. And that means that the snow geese do less well early on, and that means that this curve is lower than this curve. Now, as time passes, we still have some cases in the green in a stochastic world and none in the green in the deterministic world. So over here, the fact that we have this variation means that the growth rate in a stochastic world is better than in a deterministic world. So early in the process, there's more matches by chance alone, and later in the process, there's more mismatches. So global climate change that's causing this trend is also allowing for there to be some recovery. Now, how do you put this together? Well, you can look at the overall growth rates, and you can see that for all the stochastic models, the growth rate is about 0.9, and for the deterministic, it's about 0.86. So in a deterministic world, goose population would decline more rapidly. Now, how do you put this together? Well, it says that under catastrophic levels of depredation, climate-driven advances in the overlap of polar bears and snow goose incubation period are going to result in a decline in the numbers of snow geese nesting in the Cape Churchill Peninsula. However, stochastic variation in that underlying process is going to reduce the extent of the effect. Climate changes the mean advantage bears. Climate change alters the variation advantage snow geese. So the same process of climate change that's causing problems for the geese is also causing some problems for the bears because it gives the geese a break every few years. Every few years, the bears miss the population. Well, you have to be a little careful with models. We've made several assumptions that we need to look at. For example, we've assumed that when polar bears overlap the incubation period, they will consume all of the available eggs, this catastrophic depredation. And we also assume that when geese are depredated in a given year, they'll return to the same site the following year where they can be depredated again. Several aspects of polar bear foraging behavior could result in reduced foraging pressure. There are some folks who claim that polar bears just fast and sleep when they come ashore. This is a guy that's just swum ashore. He's on the beach, he digs a little hole and takes a nap. Others claim that polar bears will not eat snow goose eggs, even though there's ample evidence to the contrary. I showed you the picture of eggs going in and eggs coming out, so I think we can dismiss that one. There is evidence that polar bears gorge when they find a resource, although there are questions about satiation. And although we do not know how many eggs bears would eat, if they got full before all the eggs were eaten, overall depredation pressure would certainly be lower. And I'm just not quite sure about satiation with this guy. This guy weighed over 1,500 pounds. And you can sort of just see from the rear, that's a pretty wide bear. Beyond currently knowing little about individual appetite and satiation, we know virtually nothing about the interactions of multiple bears when foraging on an abundant new food source. Contest competition, for example, would certainly reduce the depredation rate per bear. The bears would be spending all their time fighting and none of their time eating goose eggs. However, as increasing numbers of polar bears begin overlapping the incubation period, the overall rate of polar bear depredation has got to go up there's just going to be more bears ashore. So we took a look at that. Oh, before that, we have to say, well, what about the stupid goose assumption? And we assumed that even if her nest was depredated, the snow goose would return to the same nesting location each year. The studies at La Perouse Bay indicate that while a female that fails will return to the region, assuming she lives, she may change her actual nest location by up to 15 kilometers. Polar bears arriving on shore are more likely to depredate nests in the coastal zone because they encounter those nests first and because the nest density is highest. But if increasing numbers of geese shifted more inland locations after initially losing a nest, then the overall depredation pressure might be lower. And of course, this might provide only a temporary respite, since the bears would no doubt figure this out, and they can certainly walk 15 kilometers without too much trouble. So in the absence of good estimates of polar bear egg depredation rates, we again turned to modeling, and we examined the entire range of possibilities from complete catastrophic depredation to no bear depredation at all. And this is the kind of pattern we found, and what we basically saw is that as the amount of depredation goes down, the number of geese that you're going to have at 25 years goes up. But the thing I want to really point out is that under anything more than 0.027 probability of depredation, snow goose population declines. So any level of depredation above a very trivial one, the snow goose population is going to start going downhill. The resource is going to be reduced. As in the case of catastrophic depredation, the rate of decline for all levels of depredation is less when we throw in stochasticity, and that's what these are the means of stochastic trials. So, how much energy compensation is available after 25 years of depredation? Several of the experts have said to us, well, the bears come ashore, they'll eat all the geese, the resource is gone, and that's the end of the whole thing. So we decided to take a look at that. And after 25 years, the overlap is going to be 12 days, which means 100% of the remaining geese will be on site, and their nests have less developed eggs, therefore they contain 49% more energy. Today, the situation is that, again, there would be 190 seal days available. That's at the beginning of the process. At the highest rate, after 25 years, there's only going to be 168 days of the resource left. Not zero, still 168 seal days. At a more medium depredation rate, which is a more realistic one, there's going to be 616 after 25 years. And at a very light rate that's still declining, there's going to be 1,700 seal days left. So after 25 years of depredation, even the most extreme depredation, there are still going to be a resource available for some of the polar bears. At anything less than catastrophic depredation level, they're actually going to have more resources available in 25 years of depredation than they have now because of this shift. Remember, the early bear gets the better deal. So, where do we go from now, or from here on this? At the modeling level, we're developing a stochastic demographic model of polar bear dynamics for the region. And we plan to link the polar bear and snow goose models once we learn more about the species interactions. It's crucial that both models integrate the increasing levels of stochastic variation expected as part of global change. Part of that increase in stochasticity was seen in 2009 with the latest breakup date ever recorded in this part of the Hudson Bay lowlands. We have records going back to the Hudson Bay Company into the late 1700s, and this was the latest year ever for breakup in the region. And one of the consequences, this is a female, this is a cub of the year, this guy should weigh 100 pounds, he weighed 300. And I want to just point out that this is thigh fat that is rolling over her foot. This is a lady who brought her 300-pound cub into the town of Churchill, and we helped remove them. He weighed 300 pounds. She weighed close to 1,000. I've never in 41 years seen or handled a 1,000-pound female. And it's just because this was a mismatch year. They got to stay out on the ice and eat a lot. So the models have to include this kind of level of stochasticity. We're also increasing our monitoring efforts to estimate the number of polar bears coming ashore during the incubation period, their use of snow goose nesting habitat, and their consumption of snow goose eggs. Now, just a couple of side notes. This is one of the employees. This is our scat detecting dog. Those are earmuffs because helicopters make noises that hurt their ears. This guy is working. Anybody that's ever flown surveys in helicopters knows that after about an hour you start falling asleep. He doesn't. Because when he sees bears from the helicopter, it's the only time he's allowed to bark at them. And he just sits glued to the window and barks when he sees bears. So he's not just having fun. We're also beginning studies that directly address the stupid goose assumption by saying what happens when individual pairs fail the next year. So we're going out and destroying their nests, marking them, and then asking, where do they go next year? To really see, is the stupid goose assumption a valid one? Part of our surveys this year, again, as part of the 2009 event, this adult male arrived on shore in early July 2009, and we watched him feed on everything from ducks to onshore seals that he captured to caribou calves. And after being darted for being in the town or near the town, he was removed from the town of Churchill by truck since he was too heavy for the helicopter to lift. And we had an A-Star, it would raise 1,600 pounds, and we couldn't move him. We're also increasing our efforts to examine the terrestrial diet of polar bears in more detail. Although it's generally thought that polar bears fast during the ice-free period, we've been collecting evidence to the contrary. In addition to determining what proportion of the bears actually consume goose eggs and geese, we're comparing their entire current onshore diet to what it was 40 years ago. It turns out someone actually looked at that 40 years ago. And the project is part of the PhD work of Linda Gormazano, and this is her Dutch Shepherd, Quinoa. In that work, Quinoa searches the coastal strips in a zigzag fashion. I was telling someone earlier, he covers about 5 kilometers for every one that I cover. He finds polar bear scat, and he signals just this way. He sits and looks, and what he's waiting for is his reward, which is a play reward. He gets 3 tosses of a ball, and then he goes on and finds some more. Now, the interesting thing is that in 3 seasons, he's found more than 1,200 piles of scat and has seriously challenged the notion that polar bears fast in the ice-free period. I know some of you aren't professional biologists, but the quick lesson is if you fast, you don't go to the bathroom. And I think the converse works too. I thought some of you might be interested. Most people don't sort through piles of bear poop, but this is just some of the stuff we found. Polar bears do eat cubs. Males will kill and eat small cubs. We're not sure what this is. We have to do genetic analysis to find out what this fur is. There's a lot of people in Churchill that put a lot of money thinking they know what this is, and we're going to have a ceremony. This is one of my favorites. It's 3 feet from a diving duck. Not sure whether it's a 3-footed duck or whether one of them got lost. And then my all-time favorite, these are snow goose feathers mixed with blueberries. Very nice mixed diet. So while the energy obtainable from snow goose eggs may reduce and delay the immediate impact of climate change on the polar bears of this region, there's other food sources will have to play a role if polar bears are to persist in the long run. We never said that they can live just on snow goose eggs. We just said that'll offset some of it. Polar bears display a high level of behavioral plasticity and capture and consume other animal prey while on land. Such foraging, especially if it increases in frequency, would further mitigate the losses of ice-based seal harvest and reduce the likelihood of unlimited harvest of snow goose eggs, which means that the snow goose resource would last longer. It's also possible that polar bears may just increase their daily rate of seal capture immediately prior to breakup, thus reducing their accrued energy deficit. Now, I'm sure a lot of you have been in bars when they ring the little bell or flash the lights and say last call. The same thing if the ice starts breaking up. When last call happens, I generally buy 3 or 4 drinks before I'm thrown out. And I'm guessing that the bears can sense that the ice is breaking up, that feeding time is over. Why wouldn't they just eat more quickly? Just a few for the road, so to speak. And then, of course, there actually have been people that talk about introducing them to the South Pole, and that's why I had to have that first slide reminding you that penguins are at the South Pole. It's our view that in monitoring the health of this species, we should pay particular attention to the bear's diverse foraging abilities and their attempts to cope with environmental changes themselves. We feel this is a much better approach than making predictions based only on their historic behaviors in habitats that have now changed. And we're hopeful that such studies will contribute to the species' persistence. In that way, we can enjoy the ends of bears rather than suffer the end of bears. I want to acknowledge and thank my 2 partners, Linda Gormazano and Quinoa. We've shared weather ranging from blowing snow to oppressive heat, hordes of biting insects, and some very tense moments with some very cranky bears. And we've had a lot of fun doing this, and I think we've learned a fair bit. Research in the Arctic costs are very high, and our work is made possible by contributions from numerous partners, the usual funding folks and stuff. But I want to make special note of these are some local companies in Churchill, Manitoba, who help us immensely. They let us stay for free. They feed us for free. They give us vehicles for free as contributions to this work. So if you ever go to Churchill and go to a polar bear tour, make sure you go to Gypsy Bakery, which has really great pastries, and buy a donut to help pay back the help that they've given us. And so I know this is really shamefully cute, but while you look at it, I'm quite happy to answer any questions anybody might have. Thanks very much. Maybe that one went off or something. Here, you want to use this one?
We're going to have some microphones for questions, so if you could please step to the mic if you want to ask a question.
Great, thanks.
So in addition to evaluating the behavioral plasticity in the stupid goose, so they may change their behavior, it seems that there would also be a pretty strong selective effect, potentially, if nesting date has any heritability, for example. And that in itself would increase the mismatch over time. So have you considered that in your models?
Yeah, we have. And one of the things is that the geese can only nest so much earlier. There seems to be a front on it, and this year was a good example. This was a really late year. The polar bears were really late coming ashore. But at the same time, the geese arrived, but the land was covered still with snow and ice, and then once it melted, it was covered with floodwaters. And those situations happen often enough that our analyses of heritability of laying date in snow geese has shown that there seems to be an upper boundary to that. And I think that's one of the other reasons that the advance is retarded a bit. There's some real selection pressure against nesting too early because you're going to get caught in freak late spring storms, or more often, there's just not going to be the habitat available yet. For a goose to nest, it's got to have no snow, no ice, and the water has to be drained out. And if not, they'll just stand around. And this year they stood around to the point that only 20% of them actually nested. This is the first year that's ever happened in the 41 I've worked on them. But there is a cap on the front end of it, and I think that's always, again, going to be slower. So I think the bear advance is always going to be a little bit faster than the goose advance. Yeah? Okay, good. The question is, what's the effect of the bears going to be on the geese and on the landscape, and at what time course is that going to happen over? A part of that I'm going to talk about in great detail tomorrow. But the short answer is that there's two problems with snow geese in coastal tundra. One of them is the resident geese, the 48,000, and there's really about 60,000 altogether that nest there, and they do some of the damage. All of the geese, the snow geese in the mid-continent population, fly up that coast in the spring. And it's those 5 or probably 10 to 15 million staging birds that do the bulk of the damage. So while the polar bears may bring the population in the Cape Churchill Peninsula under control and reduce it, they're not going to be able to catch those migrating geese in the spring. In fact, they're still going to be out on the pack ice when that happens. I don't foresee Hudson Bay in the next several hundred years being ice-free 12 months a year. So there's always going to be a time when the bears are out on the ice and those 10 to 15 million migrants are coming through. Those are the guys really doing the serious damage. Now, if you reduce the population in the Cape Churchill Peninsula, it's certainly going to help the landscape. And I'm going to show some slides tomorrow showing that if you can reduce the numbers, you start to get recovery a lot faster than we had thought in some circumstances. So I think overall the polar bears are going to help the situation, but they're not going to solve the problem. Yes, ma'am. The question is, how does climate change going to affect seal populations? And that's one of the most important questions going. And it's also one of the ones that is even more difficult to solve than the ones we're trying to work on. To do seal surveys, you have to fly over ice conditions, which means you have to be in twin-engine aircraft, either helicopters or twin-engine fixed-wing planes. And you have to be able to fly low enough to see the seals sitting by holes and by cracks and count them. It's incredibly dangerous. The Fisheries and Research Board of Canada had their crew up this year with what's called a push-pull plane, which is a very safe gadget to be flying low and slow over these kind of polar conditions. And the problem is the ice is breaking up in a funny way so that it sort of becomes a slushy. And there's no place for the seals to lie that you can see, because here's a chunk of ice and here's another chunk of ice and the seal is lying here, so you can be right over it and you can't even see it. So they just gave up, and they're going to try to come up with alternate means to detect the size of the seal population and how it's changing. And that's certainly a hugely important question. One of the ones that I've asked them is, well, is it possible that as ice is breaking up, are the seals going to start doing their job earlier, which means the bears will start being able to eat seal pups instead of in late April, they'll be able to start eating them in late March. In which case, the whole problem of lost seal energy through hunting opportunities goes away because the hunting season just shifted forward. And that, again, is something we know nothing about. If you've never been in the Arctic, it's hard to understand some of the problems and the logistical issues of dealing with doing those kind of things. It seems, well, it should be easy to count the number of seals. And it's really not. This year, out of the first 30 days I was in Churchill, with the funding to do survey flights, we got to do them 4 days. The other 26, the weather was below acceptable flight conditions. And that's part of global climate change as well. So the very process that we're trying to study is sort of throwing the monkey wrench in our ability to study it. Yes, sir.
Is there more polar bears in zoos around the world than there is in the Arctic?
No, there aren't. There's the estimated circumpolar population of polar bears is about 25,000. The zoo population is probably less than 500. And there has been a lot of success, particularly at the Denver Zoo, in actually getting them to breed in captivity. Now, I'm not really sure why we're doing that, because you're never going to reintroduce those, because the reason we're having problems is the habitat they live in is going away. So where are you going to reintroduce them? I think that having polar bears in zoos is a really important thing. I think captive breeding programs are important for that reason, so that we don't. It used to be that we took polar bears out of the wild so that people could see them in zoos. One of the things that happens in the town of Churchill, because you have an increase in human-bear conflict, as conditions get worse, bears aren't stupid. They can smell the food for quite a few miles, and they're slowly encroaching more and more on native communities further north and in Churchill. And in Churchill, we have a policy that was established in 1984 where bears that are caught in the town are darted and moved out once. If they're back in town, then they're put in the polar bear jail, which is a facility that now has some refrigerated cages in it. It has facilities for females with cubs. The cubs are actually fed. The adults are not fed. They're given water. And after a certain stay, when ice freezes back up, they're all chased out rather unceremoniously with lots of banging and yelling and shouting to try to make it unpleasant. They're chased back out on the ice. A bear that comes back the next year and continues being a problem is sent to a zoo. So in Churchill and increasingly in some of the native communities, what they're doing with problem bears is sending them to zoos. And the choice is the bear either goes to the zoo or the bear gets put down. And I think sending them to the zoo is the better bet. And there's lots of, I would say that, I've heard that 75% of the bears in zoos around the world are from Churchill, Manitoba. Yes, sir.
So at what rate are your bears declining? You're going to have cyclic patterns where things eat well and grow better and then die down. There's a cyclic pattern going on all the time.
Absolutely. And one of the most contentious issues in the whole question about polar bears and polar bear listing is whether or not the population is actually declining. And I think the honest answer is we don't know. There are advocates that the population in Churchill has declined, but if you're a serious statistician and you look at the numbers, you sort of shake your head at that. The sad thing is we don't have really good ways to estimate it. If you use traditional mark recapture methods where you go out and dart the animals, tag them, go out next year and dart them and tag them, and so on and so forth, and do the traditional ways of estimating abundance, you wind up with a very poor sampling system because this is incredibly expensive, it's incredibly dangerous, and it's hard to do. One aspect of Linda Gormazano's PhD work is if we can find the scat, we can genetically identify who left it. If we pick up hair, which we also do, we can genetically identify that. And we can then use those genetic markers for mark recapture and have much larger sample sizes. So part of her PhD thesis is to see what the abundance estimates are using genetic-based mark recapture studies. And we're doing it on this population because we already have traditional mark recapture estimates. And we want to see how close they are. One of the things that is desperately needed in this whole polar bear saga is a better way of estimating the population size and the population growth rates. And I very firmly believe that the honest answer to your question is we don't know. And I think that to say that, oh, they're declining or, oh, they're not declining is speaking out of ignorance.
It could vary plus or minus 100 a year.
Yeah, easily. Easily. Yes, sir.
Well, your studies seem to provide a lot of reason for optimism. But are there any specific management strategies that you would envision based on your studies?
I guess the first management strategy based on our studies is we need to spend more time looking at the behavioral ecology of polar bears to see how they're coping with the changing environment. And that's the message we're getting from the First Nation communities, that maybe it's time we listened to the bears and saw what it is they're actually doing. I think the second management thing that the work indicates is that we really do need to get a better handle on estimates. One of the problems now is a lot of Native communities are reporting that there's more bears. We're seeing more bears at Tuktoyaktuk than we've ever seen. We're seeing more bears at Iqaluit than we've ever seen. Well, the thing is, unless you fly the entire coast, you don't know whether you're seeing more bears because there are more bears or whether you're seeing more bears because they're congregating closer to communities because it's a better food source. Studies on the North Slope of Alaska have shown that in Prudhoe Bay, the grizzly numbers have gone way up as a result of the drilling operations because the grizzly bears have habituated to humans and they can make a better living around human habitations, even with the odd one being shot in a threat of life situation than they can out on the open tundra alone. And it's conceivable that that could be happening with polar bears. It's a circumstance I think all of us that work with and around these animals want to avoid, because in human polar bear conflict, the polar bear almost always loses. Because these guys are not afraid. Males weigh a lot. They're very hungry. They're always hungry. The guy I showed you sitting on the rock, we watched kill and consume a juvenile beluga whale that weighed about 800 pounds. He ate the whole thing over a period of about 4 days. 2 days later, he killed a 300-pound gray seal and ate that. So these guys are always hungry. And unlike grizzlies who will go off and take a nap, polar bears are going to eat. And so anytime you increase human polar bear interaction, ultimately the bear is going to lose. So I think we want to avoid habituation, but we need to see where these guys are and where they're going. And I think that's certainly the message we're getting from the First Nations communities, that they want us to see what they're doing. Yes, sir. Well, they're going to have to go to alternate food sources. And one of the things that we seem to be finding is that they are doing that. The diet analysis that Linda Gormazano has done has shown that there's been a radical change in the diet of the bears since 40 years ago. They're eating many different things. They're eating much more diverse things. And some of those things are associated with inland habitat where 40 years ago they never bothered to go. So I think the bears are exploring a lot more possibilities themselves. We watched a polar bear single off an adult caribou from a herd and then try to run it down. He can single them off, but he couldn't outrun it. So we talked to some of the elders in town about that, and one of the elders simply looked at us and said, well, I guess when he loses a few more pounds, he'll be able to catch it. And that really, though, is their view, that to jump in and intervene right now before we understand how the animals are going to react themselves is perhaps it's showing quite a lot of hubris. I mean, let's see what they do first. I take your point that we need to start figuring out management plans. There's no question about that. But I think that the management plans right now need to get better numbers and get a better understanding of how the bears are responding to the climate change themselves. Yes? Oh yeah, we have, at La Perouse Bay, we have for 41 years very happily sat on roofs and watched polar bears that come into the area run down flocks of flightless geese, and they do the same thing that I do when I round them up. I use nets that I set up and chase them into. The bears run them into dead willows and then run up and smuck them, which is a highly technical term, and then sit and eat them. And they've done that for years. Now, some of the folks have calculated that that's very expensive. And if they only chased down one goose and did that, the calculation under a whole lot of assumptions, if it takes more than 12 seconds to do that, you've spent more energy than you get. Well, there's a lot of assumptions there that need to be looked at. the bears generally don't just chase one because snow geese are in flocks, and they generally wade in and get a lot of them. There's also the possibility that having eaten an awful lot of seal, that there are other things that they are trying for. It may well be that calories is the wrong metric. And I admit that with the snow goose egg calculation, we stuck strictly to calories. But a lot of the things that Linda has found in the bear's diet are plants, and a lot of them are herbivores. And one of the things that the bears eat when they kill a goose, the first thing is they eat the intestines and they eat the gizzard. And those are just chock full of plant materials. So is it possible and they love lemmings. They'll eat lemmings. Giant bears rip up willow bushes and chase lemmings and eat them. Can't be cost effective calorie-wise. But perhaps they're going after a vitamin resource. And this is another thing, a colleague of ours, Marcus Dyke, has made some computations of things that they could be eating. But the real thing that we don't know is how the bears process some of these other compounds. And I think going back to management things and recommending for what we need to do next is we need to do some studies on some of these captive zoo animals, like they have done in Washington, like Robbins' group has done on grizzly bears, where they understand how grizzly bears' metabolism and all of that works. We don't know anything about that with polar bears. We're just guessing. We know virtually nothing about the way they extract the nutrients. And so captive studies of diets of polar bears, I think, are something that's very much in order. One of the things that's been shown with grizzlies is if you let them eat all the salmon they can have, they'll eat it, and they'll gain a lot of weight. If you let them eat all of the apples they can have, they'll eat all the apples, and they'll gain weight. If you give them a mixed diet, they'll eat 70% salmon, 30% apples, and they gain weight faster on that mixed diet than they do on either of the single diets. If you then go make field observations on grizzly bears foraging in the wild, approximately 70% of the time they're eating salmon, and approximately 30% of the time they're eating fruit. So the grizzly bears have sort of evolved with this mixed diet strategy. We don't know anything about that with polar bears, just virtually nothing. Yeah.
Forgive me, I've never been to the Arctic, so I could assess pretty weird here, but couldn't you use thermal imaging to see the seals in the water instead of using the aircraft?
The question is, could you not use thermal imaging to look at and try to find seals? And the problem with that is the ice is quite variable in thickness, and the thermal imaging signal is not very good. They've tried using thermal imaging for another one of the problems, and that's to find bear dens, and you'd think that would be a constant, but that doesn't work either because there's so much variation in the thickness of the ice. But it's something they're struggling with very hard, because knowing what global change is doing to the seals is really crucial. Yes, sir? They're just starting on that kind of stuff. One of the things that they're starting to do in Hudson Bay now is to look at the fish population, which is what supports the seals, because there are techniques available. You can do trawls and stuff after the ice is gone to look at fish populations and see how that's being affected, because we know what the seals eat. And that may actually wind up being easier, because you always have the problem with seals is only some of them are on the surface at any point in time. And so you have to decide, if I count 1,000 seals on the ice, how many were under the ice? And right now, believe it or not, what they do is they double their estimate. So we know that little about how this system works. Yeah. Seal pups? You have to find them. The fatty acid stuff is being tried with the bears, and it's getting mixed reviews. There are some control studies that have been done on not polar bears, but on other critters of fatty acid analysis. And there's some real mixed signals coming out of that. So I don't think it's nearly as good. And it's the same with stable isotopes. You really have to have a much better handle on the system than we do. Other questions? Well, it's still shamefully cute. Thanks very much for listening.
Mic there. Tell them they're sweet in the back.